All right, so here, the plan for today is just demonstrate a couple of these projects, 27 and 28. That's the plan. We already talked about these bus schedules. So let's start with 27, and I'm hoping to get some help from you on solving this. You do it your way. So here's the problem. We've got masks, and then we have assignment statements that assign base 10 numbers to memory locations. And so what this mask is all contains X's, ones, and zeros. And so the rule is it will overwrite those two bits. So you turn this number to binary, and you put a 1 in that bit and a 0 in that bit, regardless of what the number here is, and then have you got the rest of the bits from there, and that's what you assign. So let's give that a try. I already started doing it here. So what I did is referring to an array, memory 7 and memory 8. So I made an array with 16, enough room for 16 in it, filled it with zeros to get it started, and then I printed the 8th item just to make sure it's working, and it is. And then I took the mask here and put it in a string variable. Now, I found when I looked, there are Python bitwise OR and AND operations, which seems like what you need here. So if I do this, replace the X, all the X's with zeros, then I'll get the bits that are 1 left over. So I did that and printed it and got down to here. So now I have a string of zeros and ones. So if I want to take this value and I want to flip that 1 bit, how would I do that? Any suggestions?
Use the replace function.
Use what?
Use the replace function.
Well, I can only use the replace function on a string, and I've got a number here. So I mean, what I want to do is I want to add that 1 bit to the value 11. So I'm not clear how to use the replace function here. What I've got mask 0 and I've got value 11. And mask 0 looks like that. So what would you suggest? Any ideas out there? How am I going to combine these two? I want to take 11, turn it into binary, and then flip that 1 bit in a way that it'll be independent of the value of mask or the value of this number. So what do you think? Do you know how to convert 11 to binary? I think bin will do something. Let's print. It's one of those two. I think it's bin of value, but it might be value.bin. Let's try bin of value and see how it looks. Bin of value. Let's just see how this looks if I can get it cleaned up. There we go. All right. So bin of value is that. It's 0B1011. And I wonder what type that is, because then I can decide if I can use string operations on it. Let's do type of that and find out what it is. I think it's a string, but I'm not quite sure what it is. It is a string. Okay, so now I've turned it into a string. All right. Now how do I get it? How do I flip that bit in this binary object? Any ideas? I think doing it with strings is not a bad idea. One problem is this string is not as long as that string, so I want to make it as long as the other. This is 36 bits. I stated that in the problem. So how am I going to make this into the correct 36-bit string to represent that value? What do you think?
Well, we would start by adding zeros.
Yeah, okay, we start by adding zeros. I like that. So let's say, they call it binary value. Bin val, I guess we'll do, equals, let's add a bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then add bin of value. All right, let's see what that looks like. Oh, I didn't print it. All right. That stupid help message came up, can hid things for me. All right. Now it doesn't like it. Bin, I still got the thing wrong there. Bin val. Well, where's the bin val 0? Print bin val 0. Oh, actually, it hasn't. Oh, something else failed. No? Let's try this. Okay, there we go. All right. So I haven't got quite what I want. This is the mask, and that's the next string. So how do I clean it up?
Add less zeros?
Add what?
Add less zeros?
Add less zeros? Well, I could, but this is going to be a problem. This B. B is not a binary bit.
And what's it doing there?
What's that?
And how did it get there?
It got there because when you run the bin function, that's what bin does. Bin creates a string representation of a number, and in Python, it starts with 0b. That's the mark that it's string, just like 0x for hexadecimal. That's how Python labels it. It adds the 0b in front of it and then puts the number there. So how do I get rid of this 0b?
So we'll have to strip it down, or strip it out.
Yeah, over here, right? I start at the second element to the end. That should do it. Okay, now I've got, okay, I just have to get this garbage to quit popping up junk on the screen. Okay, so now I got the mask here and I got the value there. So how am I going to combine these two so that one will propagate down here? What do you think? Now, there's a lot of ways to do it. You could do it with string operations, or you could do it with the binary or and operations. I'm thinking since we're doing this, maybe a string operation would do it. There's a lot of techniques. I mean, one simple technique is just use a for loop, make result into a string, and then loop through every character. For C in mask, then calculate each bit by bit. So if the mask is 0, I leave this unchanged. If the mask is 1, I change it to 1. So that would be if let's get B equals the value, this thing, bin val, sub the one that matches the mask. Now there are a lot of ways to do this. One way would be to have a variable here that's going to count through. And in that case, the simplest thing would be to change this to for I in range, length of mask. You see the AI is filling it in there. So this is one way to do it. And if I'm looking through the mask 0 here, then I would just put them in variables so I don't get confused. M is mask 0 sub I, and B is bin val sub I. This is, by the way, a really, really old-fashioned way to do it. This is the way you would do this in 1974 in BASIC or in Fortran, a really old technique. However, that should do it. And now I can work with these numbers. But before I do anything else, I'm going to print them out. IMB, and see if it's working. And let's get rid of all this other stuff. All right. See how that works. Okay. So there's 0, 0, 1, 0, 0. Okay, that's working. And someplace down here, there should be a 1, 0. There's the 1, 0 on bit 29. And here's those other bits. So I am picking out the bits correctly. Now I can construct the answer bit by bit here with this result. So now I can say if m equals 0, then result plus equals b. You take the binary value if the mask is 0. If the mask is 1, then you add the mask. That should do it. And then we can print result. All right. Oh, let's get rid of just printing everything every time, because that's making it hard to read. There. Now, we should be able to compare these things. Okay, so there's the two things I'm trying to combine, and here's the combination. It looks like it worked. This part here is there, and that one propagated down. Now, I'm not done yet, though. If you look at the instructions, you also have to, where this 0 is, you have to change it to 0. So I have to do that. So this is one way to do it. I just want to mention there are much better ways to do it. We were talking earlier about optimizing things. But first I get it to work at all, then you can think about optimizing it. So this is getting there. And then to turn it back into the real number, you do int result 2. This is how you take a string in binary and turn it into a base 10, a real number. Number which will typically be expressed in base 10. Now but the other way to do it would be to use bitwise and OR operators. So you take the mask, which is here, bin val, and I take a, that's bin val. I don't even need to do this at all. I don't need to turn this, I can work with this number being 11. What I do need to do is I need to convert the mask into a normal number. And I've got that here with zeros and just the 1 left. So I would take mask number 1 equals int of mask 0, 2, and print that. Let's see how this looks. So here's the mask. Now it's complaining about something. I think it's mask num1. All right, there we go. And I'm going to get rid of all this stuff. We're not going to do it this way. Right. There, so mask num is 64, which I think is right. 1, 2, 4, 8, 16, 32, 64. So this number is 64, and now you can just combine it. You know the number, this value is 11, so you can just print mask num. Somebody get rid of this stupid help message. Okay. Mask num. Bitwise OR value. That should do it. All right, let's see how that looks. I think, remember, the right answer was 74. And mask, it's mask num1, I think I called it. Because it's the part that only includes the ones we're going to need to use there. That's a bitwise OR, so if either one of them is 1, the answer will be 1. And that should give me the right answer. And it does, it's 75. So I just invite you, this is the brute force way to do it, where you go through the string bit by bit and do the job, and that will get the job done. But this is where you make it more efficient, by understanding the binary. And that's why, I had those exercises where you practice learning binary. And this is why people use C and assembly code, because you work with the bits directly, and you can make things really fast if you really understand binary. But that's a tall order, and a lot of people don't. So anyway, like I say, there are different levels of efficiency. But that's one way to go here. So that's all you got to do this one. You have to use these masks and calculate various numbers. And so you'll have a program like this that gives you a mask and then has some assignments to do. They have to be masked according to the mask. And so you find a program here that's longer doing all that with various masks and various numbers being done. All right. And you just add all the values in all the memory locations when you're done. And in version 2, you have a more complicated plan where the X's mean something. The 0 leaves the memory address bit unchanged, the 1 changes it to 1, and X makes it floating, and it fluctuates unpredictably. So in this case, the mask has less X's in it, and some of these X's go through, so if the X, where the X is, you have to try every possible value, so you're going to get multiple values. And so you'll get 4 locations here. All right. And so it's going to write to 8 memory addresses. And the floating bit will take all possible values, causing many memory addresses to be written all at once. So there you go. It will make all combinations. So if it has one X, it'll write 2 addresses, because the mask affects the address, not the value. And so you're going to have some number of addresses overwritten here. Just another way to interpret it. Anyway, that's what I wanted to show you about that one. The first part's pretty easy, and the second part's a little more confusing, and that's why it's extra credit. So that's the idea. And that's the way they're all structured. There's an easier part and then a harder part. And some of them have like up to 6 levels for that reason, as we'll see in the next one. So let me stop this recording.